science-based advice, roles, principles, and practice. Anja is responsible for the Nature and Water Agreement. That includes coordination, renegotiation, reporting, expectation alignment, and quality assurance of advisory deliveries within the marine area. She's also co-responsible for the Aarhus University internal course on research-based advice. She teaches the course, and she's co-responsible for the development of the Gantt Group, which is an international collaboration on research-based governmental advisory service. And it's my pleasure to give the floor to Anja. Anja, please, the floor is yours. Thank you.
Thank you, José, and thank you, everyone. Thank you for inviting me. Thank you for the introduction, and I will briefly introduce myself and what we're going to talk about today. But this is the title, Science-Based Advice, Roles, Principles, and Practice. So I will talk a little bit about the science policy interaction in general, some of the models for that and the characteristics of the two realms. Then I will speak a little bit about the roles and framing. What I mean by that is specifically the role of scientists and experts in the science policy interface. And then I will end up about a little bit principles and practice, mainly based on the quality management system we have for advice at Aarhus University, and end up with a very few take-home messages. So just to introduce myself, thank you also for introducing what I work with currently. I have a background in mathematics and environmental biology and a PhD in environmental modeling. My professional experience is from the public sector, but I've been providing recommendations for policy since 2002 in different capacities. Since 2009, I have been the coordinator of science-based policy advice from DCE, Danish Center for Environment and Energy, here at Aarhus University. And for the past 3 years, I've been teaching at our internal training course for advisors in the Faculty of Science and Technology. And I have been teaching and participating in the Gantt Group International Science Advice Training and Dialogues. What I will go through here today is a little bit of excerpts from our teaching materials, as well as some examples. So what is Aarhus University? It's the second largest Danish university with around 8,000 employees, 38,000 students, 5 faculties. And we have these two centers, national centers for science-based advice. We have the DCA, Danish Center for Food and Agriculture, located in Viborg, north of Aarhus. And I am located in Roskilde, outside of Copenhagen, and employed by the DCE, Danish Center for Environment and Energy. But we work very much in the same way, and we work very much together. And even though I today represent the environmental science background, I speak for both centers, and we teach these classes jointly. So I will, as I said, I will do some excerpts from our internal training. And we usually start the training by discussing and talking a little bit about the science policy interaction. Where does science fit into this? So for many of you, this might be some very good background knowledge, but in order to have everyone on the same page, I will start here. So what do we talk about when science is taken up into policy and being used for political discussions and decisions? We talk normally about an interaction between knowledge and science on one side, and policy and society on the other side. And often we refer to this as the science policy interface. Throughout the literature, you can find different models, different ways of describing it and different ways of understanding it. And I will start by going through what we would call the linear model. And maybe some of you know of this as well. We have science here on the left-hand side, meaning knowledge being produced. Then that knowledge is taken over to the political realm, to the policy area, and made to make rational decisions. So this is a linear model going from left to right, where the work that we do in the universities and other scientific institutions sort of is the basis for doing rational societal decisions. So normally we can see ourselves in this realm, the scientific realm, as being identified by words like facts. We deal mainly with factual matters. We consider ourselves independent. We often use words as objective, neutral about this realm. We consider ourselves bearer of the truth sometimes. We often also in science deal a lot with standardization. Things are general. We can use the words as validity. We have explanation for things, and we are founded in reason mainly. So these are some of the words that we often use in our realm of science. On the other hand, policy, as you can say, is sometimes associated with a lot of other names and labels. In the policy realm, outside of the scientific realm, we deal mostly with values. There are a lot of interests at stake. It's you're supposed in the political realm to be representative of specific interests. You are subjective. You are allowed to have your own matter or your peers' matters in mind first and foremost. We deal not with something called truth, but more with ideology, and there are also matters of power. And instead of standardizing across different facts and data, you can negotiate which data or which facts are more relevant. So we deal here with negotiation. We attract support for our opinions. In this realm, we are also very keen on taking action, not explaining why things are, but to understand what to do about it. And instead of dealing with reasoning and logic, you can even have cunning and power battles in this realm. So these are very different words that we put on these sides of the matter. So there are some implications of this understanding, this linear understanding, that we come from science and rationality to rational decisions in the end. So for one thing, once we see this as a linear process, we tend to, as scientists, to focus very much on knowledge transfer. We need to make knowledge known in the political realm, then they will know what to do about it. We have a lot of focus on communicating our evidence to policymakers and inform policy and educate policymakers. But sometimes we hear things like, if we all agree on the facts, then we will know what to do. So this is something you can hear in this type of understanding, in this model, that scientists will say, the politicians are not taking actions of this, but if they just knew what I know, then they would take some action. So we often also hear this saying that the lack of political action must be due to lack of knowledge. We need more knowledge and we need more research. So please send more money and then more will be done about this issue. I don't know if you know of any types of situation where this has been the case, but sometimes you can hear that when you discuss, for instance, climate issues among scientists, saying, well, we need more research so that the world can take action. So this is an example of that type of talking. Sometimes we even talk about the science policy chasm, that there is, we have to bridge this gap and bring knowledge from the scientific side to the political side so that they can act upon it. But sometimes things do not work really like the linear model. There are some complicating matters here, right? For one thing, we are not a completely isolated part of society when we do research. We are fully dependent on the research policy and the research funding, and that comes from society and from the political level. Very much so in the moment at the European level, where we are waiting very happily waiting for the new framework program for research, the horizon, then it becomes very clear that what we can do and what science we can produce in the future is very much dependent on what the policymakers frame this framework and how money are being used. So this is one example, that we are not sort of distant from society, right? Another confounder is the society in general. This realm, this scientific world, you guys and myself, and then the policymakers, we are not the only players here. There are other members of society. There is the general public, and they are going to choose, elect politicians, and so their opinion and feelings matter as well. And we have the media through which these voices are being heard and mediated. And we have the NGOs, the different interest groups, farmers, the green NGOs, the interest parties, the lobbyists, and all of these are a part of this picture. So they are not either part of science or policy, but they are a part of how policy take up our knowledge and how it's being used. And then there are individual values. I will get back to this in a minute, but there are individual values in the policy realm of the politicians, also in society, and also within the scientific community, obviously. So this means that the idea that this is an ecosystem that moves straightly from left to right here, that there is a linearity to it, that we alone determine what to do, and then it's taken up by policymakers, and then they make the decisions. That it's maybe a little bit too simple. So the linear model is maybe a good way to start discussing things, but maybe it doesn't really work that way in practice, right? So then what is there? Different models of this. Then there is a policy-driven model. And you can see here the interest arrow is going the other way. So in the linear model, we as scientists on the left side, we produce knowledge and deliver to the policy realm. So that's the policymakers and the civil servants, right? But in this model, there is also a red arrow pointing the other way, so that the interests of the politicians, and as I said, for instance, the funding and the funding programs and the research programs, they push down on us in the scientific community, and they determine also what type of knowledge is being produced. So in this understanding, the political arguments are maybe even as valuable or even more central than scientific knowledge when decisions are being made. And scientific knowledge is only taken up actually and only listened to in the political domain when it serves a specific purpose or interest. If you have been working in an area where a little political action has been made, then you might have been in a position where you think this is sometimes more relevant or more true of how things work. And sometimes scientists can be a little disheartened when knowing that I have been producing this evidence and producing these reports for 10 years and nothing has been taken up. And then suddenly maybe the political will shifts. There is maybe a new government, and then suddenly everything can be done, and they will take up my work because now there is a room for it. And this is an example where it's more or less interest driven when science and scientific evidence is taken up or not. Then there are some more, complicated models that are maybe a little bit difficult to analyze or even to be taken part of, but maybe a little bit closer to the truth, seeing all in all that all things are happening at the same time. And in this model, we can call it an interactive model. In this model, there is a dialogue ongoing all the time between science producing knowledge and the political realm that we produce it for, but also co-production, that we are able in the scientific community to stay relevant by producing knowledge in a way that it will be taken up and that when in the time when it is needed. So in this type of setting, knowledge as well as interests are included in the basic work that we do, but also in the decisions. There are venues of productive interaction between scientist and policymaker. This also sometimes in literature described that it works maybe best in a setting where there are some level of independent civil servants, where not all civil servants are also political actors. And in the best possible world here, there is a deliberation and joint fact-finding between this scientific world and the policy world, and co-creation of both research questions and methods. So in practice, when we have these type of interaction, often we have what we call boundary organization. And these are either areas within the scientific domain or policy domain or independent actors that take upon themselves this role as being in the middle and being translators from science to policy. And here you have two new arrows as well, and one is push and pull. And these are examples that sometimes the scientific domain produce advice for policy to sort of take up and listen to, because we see that something is needed. And sometimes there is a pull, where it's the policy domain that sort of gives us the question for the science side. But these boundary organizations can often work with more different ways of working as well. So often, as I said, the focus is actually on the co-production of useful knowledge to evaluate the quality and relevance of existing research and to produce policy advice in close dialogue with these requisitioners in the policy domain, and to engage in design policy instruments and engage in the dialogue. Examples here in Denmark are the two centers, DCA and DCA at Aarhus University. So even we are in the scientific domain, we have tasks that help in this dialogue. International examples are the IPCC. So the policy cycle, very briefly, I can see that I'm taking more time than I had hoped. I don't know if you all know of this policy cycle, but the different steps taken on within policy to develop new issues and new agendas is often defined by this: defining the issue, understanding it, develop and assess options to act, and assess the risks, and then formulate the policy and implement it, and monitor and evaluate. And often we see that scientific input is mostly important before the policy is formulated, to develop and assess the options and to assess the risks of the different options, but also in the agenda setting, there is also a room for scientific input if something needs to be put to the political agenda. So what characterizes, this is a little bit reiteration, science deals with facts, policy values. Science is considered independent, where policy is interest-driven. Science is neutral, while policy is subjective. And we have on one side truth, and the other side ideology and power. And we standardize in science, but where policy you can negotiate and you can even win over what is considered the truth. And we have validity and explanation on the left, but demand support for our visions and need action. So some of the barriers that comes out of these differences is that science is often very discipline oriented, while the policy side deals with things that are inherently complex and needs to see beyond one discipline at a time. In science, we use very much abstractions, for instance, models, where in policy we need to extrapolate and generalize results. In science, we often have very long-running projects and slow evolvement of knowledge, but policy very often moves faster, right? And demands answers also on projects that has not been finalized, and sometimes you have to give answer even before you feel that you're ready. So these are some of the barriers evolving science on one hand, but that's policy demand that we are consistent and stable and give the same answer year after year, so that they can build political formulate decisions and laws and so on and top of that. So a little bit about the roles and what that means in the science policy interface. How do you as scientists fit into this? Well, if we should see it in context of these three different modes of working, if it's knowledge driven, then we have the scientist as a knowledge provider, servicing policy, describing what is. That is one role you could take in this interface. In the other more interest-driven interface, where you have the hypothesis that everything is being interest driven, then you might, as a scientist, take the role of an advocate, taking one interest over the other. And in this role, we describe as an activistic role or an issue advocate. In the final setting here, where there is co-producing knowledge and co-production, we often describe this role as being a diversifying, describing what could be instead of just what is true. And then we can consider ourselves knowledge brokers in this role. So in order to tell which role you have to be very aware of your own values, right? Because if you act as a service provider or a knowledge broker, but you have some inherent values, then you become a stealth activist. So this is why the next slide here is important. When we teach our own class, I show them this slide and I ask the whole class to tell me what is in the picture. And I get, as you could probably see for yourself, many different types of answers. For instance, maybe the first person says, I see a windmill, so this has to do about renewable energy sources. Another person in the class might say, I see the cattle grazing, so this is also about agriculture. And there might be a person in the class saying, I see the waterway here, and I see that it has to do also with ecological status in the marine areas here. So we see what is close to our heart, and that is very natural, because even though we all see the whole picture, what we choose to focus on is where we value the most. And this is nothing wrong with that. It's just the way it is, but it has some implications. This is also true when we as scientists look at a scientific problem. We have to narrow it down. We have to choose some aspects, some data to focus on, because we cannot focus on everything all the time. But it does have implications. For instance, if I say that this is a landscape, then I have put this picture in a category with other landscapes. And that might give you other pictures in your head, like, for instance, a mountain landscape or a desert landscape. Then this picture becomes something special more than just the picture. At the same time, if we focus on the cattle and talk about agriculture, then that becomes the most prominent thing in this picture, and this picture is then related to other agricultural pictures. You get my point. So why does it matter? It matters because it complicates this, right? Even though I put here the linear model, you know what I mean when I just say the science policy interface, but the existence of these frames that you focus on what really matters to you, that complicates things really a lot, because we are no longer just dealing with facts versus values. So everything I told you that we consider facts in the left realm here, and we are objective and neutral, that's not maybe so much the case, because which fact did we choose to focus on? And why did we choose these facts over other ones? And who are they relevant for? These are some very important questions we have to ask ourselves continuously if we want to stay true to close to our scientific ideal of being objective here. So also, once we have become aware of this framing that we consider with the issue, then be also dare to ask what could be an alternative framing. So what do frames do? Frames help to identify the important parts of a complex system. So we choose in our methodology when working as scientists that which facts and data are relevant with methods of data collection. And one example I will give you here that I use in our class is, for instance, a forest. In a forest for a hiker, the very most important thing would be to focus on how to get there, where to park my car, what are the trails, how is it signed, and that would be an important part of that being a good forest for you. For the logging company, the focus would be on the value of the timber. How old is it? How easy is it to harvest and so on? And for the biologist, the focus would be on the habitats and the species and the microhabitats and the dead wood on the forest floor and so on. So there are different perspectives. There are different answers to the question of what constitutes a good forest and how to improve it. And how do we identify these frames? You do that in the language. How do we define, name, and characterize things? And especially, it's a good idea to look for clues. If you read a scientific paper, you can already find them in the introduction. In general, we can start considering what is included or excluded from the analysis and what are the metaphors that we use and what narratives do we use. So as a final thing about framing, I would just say that also sometimes we have institutional framing. That is, when multiple actors see the world through the same framing, it can become embedded in the way that we work, both through practical or even physical structures, the way that we analyze things, the way that we measure things. And there can be dominant frames that both the authorities, the policy side, and the research side is a part of, and nobody maybe even questions. And therefore, it becomes even harder to identify for us as scientific actors. So the implications for the role as an advisor. If you try and maintain the distance and be a pure researcher or in a servicing role, there is a risk that your knowledge will not be used if you do not share the framing with the policy side or with some of the dominant interest group. There is a risk of bias by ignoring knowledge that do not fit into a dominant frame. And for instance, if the client requests some specific knowledge that fits into a dominant frame, then you would never get the idea to start and widen that frame if you're not weary about this. If you want to engage in a diversifying role, an advocating role, and go into this discussion of what could be, then you have a risk of being influenced by your own values in this and your own framing, consciously or unconsciously, and you risk losing your professional credibility and trust. So implications are that when you operate in an area where there are multiple frames, you as an expert risk being perceived as a partisan voice, as an advocate here, rather than a neutral authority, even if you work highly scientifically. Thus, the scientific standards alone does not ensure high credibility when doing advice into policy. So this is a main take-home message here. So then what? Then you have to work to increase your credibility. And what we do, and some of the things that we work with at Aarhus University, I will briefly go through that, even though I've reached half an hour, is about be transparent and explain the decision and disclose the ties you have with different clients or funding. Broaden the perspective of the problem, avoid polarization, and allocate time and resources to all sides and all different views on the problem. Show some humility and admit biases and admit knowledge limits, and embrace diversity and value disagreement without suppressing it. This will increase your credibility in the scientific domain. I will briefly just use a couple of minutes, hope it's okay, José, to say a little bit about what we do in terms of quality management to ensure some of these principles when we work in practice with scientific advice at Aarhus University. We have a quality management system that has these overarching goals to maintain a high academic quality, to stay always within the agreed deadlines, to always be based on the research activities, and to include all of the relevant research competencies. We have a goal of being highly efficient, transparent, and merit individual researchers, and always published. So this is a picture that I draw a few years back about what goes on during an advisory process at Aarhus University, going from left to right. You go through the unit, either DCE or DCA, when you get a request from the ministry. Then you start the task by setting the right team so that you ensure to have all the different perspectives on board and the different competencies. You make an agreement. Then we have carrying out the task where there is a quality assurance of models. And when there is a steering committee, we are very transparent about that. And we have minutes from the meetings in the committee and so on. Then there is a product in draft, and then we have a quality assurance of the product. We have a peer assessment. We have DC or DCA employee reading it as well, and we have linguistic quality assurance. Then we have a commenting round. We can have that with our requisitioner in the ministry, and there we are very transparent about that as well. So we have there an appendix, and we write every comments and the handling there, and we publish that in the end of delivery. We deliver it to the ministry, and we publish both the publication and this list of comments that we've received in order to stay transparent. So these are the principles. Just to sum up, we have a principle of high academic quality grounded in our scientific work. We have a principle of independence, maintaining arm's length to these focus groups throughout the process. We have an ambition to have high consistency across time, over time, but also between the different teams within the university, so that you cannot ask two different groups and have two different answers. We have a high level of transparency. We publish the results and we document the dialogue along the way, and we have integrity, ensuring that these principles are upheld. So take-home messages, and then I will wrap up. No advisory role is free from values. We are not neutral. But it is possible to maintain high credibility and authority while delivering useful and relevant knowledge if you know your audience, where and when a decision being made and by whom. If you reflect on the framing, which values are at play really here, and you work to increase your credibility, for instance, by some of these principles, and be open about your own limitations. So if you want to continue this dialogue in an international setting, I can recommend going to this webpage with the Ghent group that we started up along with good colleagues a few years back, and we had some training sessions, and we have a yearly meeting and seminars, and you can join us there for very good discussions on how to do this more and better in an international setting. So that was all for me. Thank you.
Okay, thank you, Anja, for the wonderful presentation. It was really, really useful, I believe, for a lot of people. And we've got on the chat box quite a few questions, so let's try to go through some of them. First question is from Guy Klessons. He says, are you, as a scientist, free to choose your own research topics in the linear or alternative model? And related to this, he also asks, are also lobbyists involved in those models? So can you please reply to that, Anja?
Thank you. Yes, in principle, researchers are always free to choose methods and work, right? But in practice, when there is agreement with a requisitioner, then sometimes you can only choose your own methods, but you cannot choose your own topic. If you in a position where you work for organization like we do at university, but we have an agreement with the ministry, then sometimes it's the ministry who asks the question, and then they decide what topic you have to investigate and then to answer that. But we are always free, also in this setting, to choose our own methods and data and so on. Then the other question was, is there room for lobbyists? Yes, the lobbyists are clearly a part of this picture, which is why it complicates things, right? They are, especially in this interest-driven, but also in the co-production model, they can have a very strong impact on the policy side in determining how science is being used, and they can, and we have seen this also in Denmark. I'm sorry to say, lobbyists can be very scientific in their way of working, and even try and undermine good science by claiming it to be flawed or not useful, and using this inherent discussion within science to to say, well, the scientists themselves are not even in agreement on this, or they can find, this one dissident scientist that they can always find one person, because we do disagree within science, right? And we have seen in the past years that lobbyists, especially within Denmark, are more and more using science as a tool in their work in the science policy interface. Yeah.
Thank you. So next question, Frédéric Lemaitre, he asks if you have a source to cite for citation for these models. So if you have, please put them on the chat box. If you don't have it right now, we can also send it later to the participants. The other question is also from Guy Clesson, is with your experience, which is the best model to make the best transition shift?
Oh, yeah, transitionship. They have to do with there being political will to action, and maybe not so much if there is scientific evidence or not. So I would say that the model that works best there would be co-production, so that you take the problem owners, the interest groups, the politicians, the civil servants in the same room, maybe even physically, as the scientists, and have them define the issues, define the problem, but also help them voice their concerns, their barriers, and give their framing. And as a scientist, then know what is at stake, so that when we then research the problem and give our scientific result, then we have taken these different interests and layman knowledge and so on into account, not to make it an unscientific type of work, but to make it a more comprehensive work that is maybe easier taken up and more easily accepted, because we are not seen as being a part of a framing that, for instance, the farmers cannot recognize. So the more that we listen, the more relevant we become, and better it is taken up as part of the transition. That would be my point.
Okay, thank you. So from Rock Science, we have not really a question, but rather a comment. He says, I work with agriculture and the lab is very different than in field. And we know some studies are more highlighted than others. So I'm really into this topic. Look at what is happening today with the French farmers. Science says, kill those cows. So let's check this webinar to understand better these methods and how policies are done. Thanks for this space. So I don't know if you want to comment on this. But the next question is, how can we optimize all the frames so we get closer to the whole picture?
Yeah, I think that is a very good question. I think as a scientist, as I said before, it has to do with being more reflective on your own practice and more curious about your own limitations. So once you start at least asking the question, what is my framing bias here? And whose values and interests are at stake? And are those necessarily within my scope of work? Or have I sort of somehow left them out because I didn't feel that they were relevant to the scientific part of the question? So in order to have these frames meet, sometimes we need to be in the same room, but also sometimes we need, as a scientist, to maybe be better at challenging our frames as well. And sometimes we need to listen to the criticism where, in the cases that we are being seen as irrelevant. If science is being seen as irrelevant, then probably we have a very narrow frame that is not being seen as relevant for the people that is going to live with the decisions being made. And there are some examples in history. One of the examples from the textbook that is outside of the agroecology and outside but a little bit from the environmental area is fracking. Fracking was being seen from society policymakers and entrepreneurs as something that could be handled, a risk that could be managed, and they asked scientists and geologists to map this risk and to try and understand this risk of environmental harm due to fracking. And the conclusion was that the risk could be managed, it was quite small and so on. But it was never accepted in the public. There was a different frame. leaning more maybe to the precautionary principle that no harm should be done whatsoever. And so that knowledge, that risk assessment by the industry and by the governments were never taken up and was never accepted. So I think we have to be very wary and listen to the people who don't like what we are saying and understand why, in order to be able to enlarge our own framing.
Thank you. Next question from our colleague Stefano Grando. He asked you if you agree with this comment. He says, which facts? It's often shaped by policy demands, funding opportunities, etc., which in turn are influenced by previous research outcomes, but also by emerging social pressures. This is maybe truer the more we move from basic to applied research. So the question is, do you agree with this?
Yes, I agree with it insofar that I have experienced this myself, that also when I talk about institutional framing, that when we stop even asking ourselves the question, which facts, because it just, it's obvious, it's the normal facts, because we have these measures in place, and we might even have international conventions based on one specific way of looking at this, or one specific set of indicators. So we don't even concern ourselves so much anymore with which facts. So I think a wise thing is to ever so often to stop in your tracks and really see if there are other ways of looking at the problem, and which things have not been investigated due to lack of funding, because funding is being funneled to the usual topics and the usual suspects. And then as a scientist, have the courage to also say, yes, I will investigate, but only if you also investigate the other side of this issue, and the people, for instance, standing to lose from these type of measures.
Thank you. So we've got another question from Bianca de la Cruz. She asks, in your experience, how much does ethics and its principles, societal benefits, come into play in the science policy interface? I feel like this should be a given in policy development, but I wonder how much of these are actually accounted for in the process.
This is a very good question, because ethics is very, very hard to deal with in a scientific context. And sometimes I think we also become a little bit blind on how different ethics can be. And basically ethics is also framing, right? Ethics, it's about what is important, and then what is even more important than other things. For instance, if we do what you can call an economic and evaluation, a cost-benefit analysis of what is better, which road is better. We do pros and cons in terms of financial, and that's a type of ethics that is sort of value driven, that you can base everything, you can put everything on the same scale, right? That you can monetize everything. So that's utilitarianism. That's an ethics, that everything is equally valuable and you can trade one commodity for another. But there is another ethics here as well, right? That we have some sort of obligation to preserve the environment, and these are some of the conventions are built in this. There are many different ethics. There is an ethics concerning animal welfare. They could not put on monetary value. So ethics is sometimes really the same as framing, the way you look at things, but it also is about the limitations to your analysis. And I think the best way to go about it is to be very open and also be, again, self-reflective about where you stand. And if you can then describe it in some way, saying this analysis is based on these and these circumstances, then people are maybe more open to make use of it if they can within their own ethics, if you know your own limitation.
Thank you. And now get ready for a huge question, massive question. So Rock Science is asking, how can these science policy methods fight corruption and corrupted people, including scientific and policymakers?
Oh, that's a big question. How to battle corruption? I think that lies outside of this topic of today about science to policy. I'm not sure that any science or uptake of science in the political realm can alleviate that. On the other hand, we do have a responsibility as scientists, right, to make sure that corruption and the money talk thing, that the funding and where the money flows decides what we do or not do, and to fight that at least by being transparent about who is paying and for what.
Okay. Next question is very related with your activity. So they're asking, Email Saud asks, you're a qualified environmentalist. Have you done any research on climate smart crops like finger millets?
No.
No.
Probably someone at University of Aarhus, but not me myself. No, I can't answer to that.
Okay. And another question is, plenty of literature advocates research in agrobiology to be transdisciplinary, participatory, and action-oriented. With this in mind, I would say the possibilities become automatically narrowed, and we should focus on this path. So do you want to comment on this?
Yeah, I'm not sure I understand what the question is, because the question says,
I believe it's more a comment than a question.
Yeah, exactly. So the person states that I would say that the possibilities become automatically narrowed when it's transdisciplinary, participatory, and action-oriented. I would say otherwise. I would say that when you have other people than scientists in the room, usually what happens, especially according to some of the cases in the literature, is that the possible room for possible actions is widened, and the understanding of the need for action is also often widened among the actors in these participatory dialogues, and the acceptance of the resulting measures is often higher if you have the actual problem owners and interest groups in the room while you discuss possible action. So I would say that the possibilities for action is often widened if you do participatory research.
Thank you. Now, the other question is, are you reflecting your projects or research topics directly with the farmers? Or in other words, do you include the practical knowledge of the farmers?
I would say that depends on the specific projects, what we do at Aarhus University. Sometimes we discuss also the project beforehand with farmers' organizations, and we are very transparent about this when we do that. So there is a process of interaction, and sometimes we do not. So that depends on the type of the project and what we have been asked to do by the ministry, or what the research project itself is about. So that can happen. To include the practical knowledge of the farmers, I would say, without being from the agricultural side of the university, we try to do as much as possible, and as to stay relevant and useful. So I think we strive to do that in all relevant projects. Yes.
Thank you. So next question comes from Adelia Varela, and she's asking, considering the challenges of modern agriculture, in your experience, what are the most promising ways to integrate ecological principles into crop management while maintaining productivity and resilience?
I think that lies outside of my line of work to say what are the actual solutions, but I would say that the solutions should probably be sought in a broader context than just a scientific setting, right? Because there are many actors in this field, and they have to, if you find a scientific solution that is very technical or very sort of academic, then it has a lower chance of being taken up and being useful and create the productivity and resilience that you would have needed. So again, my answer would be to have, the way would be to have processes involving the actual farmers that are going to be using these new principles.
Okay, thank you. Next question from Manuel Rodriguez is, the soil monitoring law has just passed the EU level. What role do you see for agroecology in this law, and how do you feel about the minimum requirements for monitoring, but not specific action targets approach?
And now it becomes, again, a little bit very specific about soil and soil monitoring that I have no knowledge about personally. So the role for any law is seen in the scientific context is to be monitored and evaluated. So we are then in the process, as I said, with the policy cycle, then science should really have a big role here in order to create evidence, in order to evaluate the law further down the line, evaluate for usefulness and impact and relevance. And there, I guess the monitoring, as it's been described, is a minimum level, but if research projects can then contribute to that, we should be sure that this knowledge comes back into the policy cycle at EU level so that the law can be constantly evaluated and monitored.
Thank you. So the next question is, how would you bring knowledge management into the domestication of orphan crops and bridge the science and policy interface?
Again, this is not my line of expertise, but to bridge the science policy interface, there are many ways forward, and it really depends on where you are at in the policy cycle, if you're working nationally or internationally, and where the decisions are being made. And I guess I mentioned this in the end, but without giving you a very good set of tools, because this was not the focus of my talk. But for all of you to have any type of impact in the policy system, you need to know whom you're dealing with. On your specific topic, where are the decisions being made, and when, and by whom? And in order for you to then bridge the science policy gap or interface, then it's up to you to make sure that your knowledge is relevant for these people making the decisions at the right time. So if you do not have a setup, as we do in Denmark, where we are very, very closely related to our ministries and government and being asked questions in good time before law is being prepared or even being implemented or evaluated, then I would recommend that you see that as part of your task if you want to not just be a researcher, but to be a researcher working in the science policy interface, to have that knowledge at hand and to have ways of sharing that knowledge within your research networks.
Okay, thank you. So one last question. What's your experience with the relationship between scientists and journalists, with science and media? Because the feeling I had, the media is mostly interested in breakthrough discoveries that are going to give you the Nobel Prize, or on the other hand, catastrophic news that everybody is going to die with this type of food. So when you want to deliver useful information, how easy is that in your opinion, and how can you establish a good relationship with the media?
That's a very good question, because the media thrives on conflict, right? So we become more relevant as scientists if we go outside of our expert role and become a part of a conflict. And then we are no longer seen by the outside world as being this neutral observer or even credible providers of knowledge. So there is a very fine line here. And sometimes it's okay maybe to cross that line and become the activist if we really feel that now I cannot be a bystander anymore. Something has to be done. And I have colleagues who do that, and I value that very much. But if you don't want to take that role and be seen as a part of a conflict, then you really have to be very aware, as I said, with the fracking issue. What are the actual conflicts? Is there a frame here that means that no matter how scientifically you work, no matter how many references you have to work and how well you work, and even if you have the Nobel Prize, someone will criticize you and you will be seen as part of the problem, not part of the solution. So be really aware of who is out there trying to make you the bad guy here. And once you are aware of that, and the more you can sort of embrace these different framings and say, I know that there are some losers in this area. I know that there are some that do not want fracking, whether I tell them that it's safe or not. And the more you're aware of these things, then maybe you can also have more people listening to you, but you will also be seen as a more boring expert in the terms of the media, because they do not like you to just stay on your side of the story, right? So it is a fine line to become of interest, but without becoming boring. And I would suggest everyone to actually maybe team up with some of the ones that normally is seen as an opponent. And if you approach the media together saying, even though there are these strong views, this is still the science that we are agreeing on and we can build on. So maybe even try and approach and view the media as something that can be jointly approached by you and others in the science policy interface and in the community.
Thank you. Well, still have time for one last question, just got in. The question is, monocrops justify the agrochemicals mindset? Monocrops are more vulnerable to climate change than polycultures?
So that's a question about a specific type of crop, but I also see it as a question about framing. So yes, I see here a good example of framing, that in this agrochemical framing, then monocrops are a good thing, but with outside that framing, it is maybe a more complicated matter, right? So this is an example, like many other examples I'm sure you have out there, where the facts and the truth about something is really dependent on what type of framing you're in.
Thank you very much. So that was the time we had for question and answers. Thank you very much, Anja. It was really, really useful. For the people who were not online when we started, let me just repeat that we are recording these sessions and we'll make the links available and we'll send them by email to you as soon as they are ready. And you can ask questions using the chat box. And at the end of the presentation, we will give the floor to the speaker to answer those questions. So I believe that our next speaker is already in line, Cristina Branquinho.
Yes.
So
do you listen to me well?
So, sorry, yeah, your sound is well. Yeah, so you can share your screen. And while you share your screen, I'm going to introduce you. So the title of the next talk is Agricultural Productivity in Times of Uncertainty, an Ecological Perspective from Resilience to Tipping Points. Cristina Branquinho is a full professor of ecology from the Faculty of Science of the University of Lisbon and a researcher at the Center for Ecology, Evolution and Environmental Changes, where she leads the thematic line towards sustainable and resilient ecosystems with 12 research groups, and leads the Systems Ecology Research Group, which aims to understand complex ecological systems and promote resilience and sustainability in the face of Anthropocene challenges. Cristina, it's a pleasure to have you with us. The floor is yours.
Okay, thank you very much. So confirm that you are listening to me well?
Yes, the sound is perfect.
Okay, because I had some problems. So thank you very much for inviting me to this class on agroecology. So I choose the topic of showing some of the results that we have on agriculture productivity, looking at an ecological lens, because my basic formation is biologist and I'm an ecologist working a long time in these semi-arid Mediterranean types of land. I would like also to acknowledge the work that was also done in collaboration with Maria Espírito Santo, Ana Paula Portela, and Maria Alexandra Gomes Oliveira. So I would like to start by saying that grasslands, which the vegetation are vegetation dominated or co-dominated by graminoids with varying types of densities, has a global distribution in the world covering approximately 40% of all the area. And in particular, pastures, they are associated with feeding more than 2 billion people. So they are really important types of land use. And those pastures, they provide several ecosystem services, starting by food and feed, carbon sequestration, control of soil erosion, water flow regulation, pollination, and habitat. Despite not being very valued sometimes in agriculture systems, they especially their ecosystem services delivery is quite high what concerns the regulating ecosystem services, such as you can see here by this type of graph. So pastures are really relevant, not only because they cover a large part of the planet, but also because they provide several ecosystem services, which really build an amount of money when we try to translate that to monetary value. And so one of the important things to understand the system is what type of determinants of this ecosystem functioning and productivity, which type of determinants there is. And what we know is if we look to the primary productivity of these systems, which is what agriculture is mostly, in fact, view, they really depend on the climate. They depend, of course, on biological communities, which by its turn depend on climate, and also the abiotic components, and on the management, and of course depend on those abiotic components, such as soil properties, for example, which again are dependent on climate and management. So there's a really integrated relations that sometimes is difficult to disentangle, and this primary productivity is a result of the interaction of all these determinants, and which are not easy to clarify. And of course, the primary productivity in a lot of circumstances might be related to several ecosystem services as well. And I also would like to acknowledge that the relations that exist between climate, between all those determinants and the productivity and functionality of the system are not necessarily linear. Sometimes they are non-linear. Of course, this type of pasture lands we have depends very much on climate, as you can see from this graph, and the climate is being changed a lot. So we can see from this type of graph that the last years represent extreme situations in terms of climate since 1940. So if you look even 2025, it's really on the most extreme years in terms of temperature, and of course there's also extreme if you look at precipitation values, especially in Mediterranean areas. And I also would like to acknowledge that at the present time, Europe is warming much faster than the global average. So Europe, as you can see here, is warming compared to, of course, Arctic is warming even faster than Europe, but Europe is warming twice as fast as the globe in general, meaning that we really are in a hotspot of climate change, and we will reach the 1.5 degrees very soon at this rate. So we really need to understand how our systems will react to this climate change, and also how can we adapt to those conditions. So that's why I bring here some concepts of resilience and resistance. So we know that most ecosystems and most natural ecosystems are resilient. For example, we can look to the tropical forest here in Daintree rainforest in Australia, or the Amazon forest, and they have been there for millions of years. So most natural ecosystems are really stable. and they, after disturbances, they are able to bounce back to the previous situation. And it's important also to notice here a concept of resistance, which is not really affected by a disturbance factor, such as we can see here in this case, or resilience, which is the capacity to recover or bounce back following a certain type of disturbance. And so it's important to understand how natural ecosystems are resistant or resilient to disturbances in order then to improve our capacity to adapt to this very fast climate change that we are suffering. An example of how this resilience works is that we can look at, I'm not sure if you see my mouse. Can you just see my mouse? Yeah? No. Well.
Yes, we can see.
Yes, you can see. So we use sometimes this type of description, which is basins of attraction. In this case, we have a forest, which has two, let's say, similar states. They can have, two different states for the same type of system. So we have one site, we can look at this type of forest state, and it's very difficult if you look to this ball and look at the basin of attraction. It's very difficult for this ball to get away from here if the system is resilient, because if it changes and go to this place, it can be a savanna. But for example, this is what is represented by this type of situation. Once we do a clear cut on a tropical forest, as is represented, we change the hydrological system that once was really retained in the area. So we got precipitation, which was infiltrated by the system and then got evaporated and then retained by the system. So let's say that the amount of runoff was quite small. Whereas if we go to a place where there was a clear cut, what we will have is an increasing amount of runoff. So that's less water getting evaporated and retained in the system. So we in a situation where we have, for example, a clear cut, instead of having these two balls of attraction, which are more deep, we will have a ball of attraction which is not so deep, which means that it's representing lower resilience and it's easier to go to a savanna state. So in this situation, if we get a certain amount of less precipitation is retained in the system, and the potential of going to a savanna gets more probable and going to a savanna state. And this happens in different situations. So let's imagine we have external drivers, such could be climate change, could be increasing in temperature or decreasing precipitation. And for example, we can have this regime between a forest and a savanna. So once we get warmer or we get less precipitation, we can get a linear response in ecosystems. But most of the times we don't get really linear responses. We get non-linear responses, which are normally associated with the threshold or tipping point, where a small amount of the increase in temperature or a small amount of decrease in precipitation leads to a completely different state. Okay, so the worst news from here is that sometimes when we want to go back and get the same levels of precipitation or the same levels of temperature, we are not able to recover the system. So as you can see here, sometimes we have hysteresis. So we go back to the precipitation and temperature levels, but the ecosystem does not recover immediately. And in some cases, it even collapses when certain functional groups are really local or globally extinct from the region. We cannot really recover completely the system. So this is what frightens us in terms of the system. So an agro system is also, of course, it's an agro ecosystem as well. So we can look in the same perspective. So we will try to look to these agro systems in an ecological perspective to see how we can improve the knowledge to agriculture. And one colleague, Miguel Verdugo, investigated how these tipping points would occur, for example, in dry lands, which is in the case of Portugal, where most pastures are located. And in fact, he identified 3 tipping points along a gradient of aridity in the dry lands. The first tipping point was related to the decay in vegetation productivity and photosynthetic activity. The second tipping point was more related about the soil component and, for example, the changes in microbial communities, namely, for example, the decline in ectomycorrhizae. And the third threshold was a drastic reduction in plant cover and, of course, plant productivity, increase in soil albedo, and also the shift to specific plants which are really avoiding the stress that are performed there. So we identified these 3 tipping points by using a series of variables that is studied along this dryland ecosystem across the world. So this was reproduced across the world. And you can have a look on those tipping points, how they look like in terms of data. What about Portugal? So in Portugal, the data that we have from the Conservation Institute and the Forest Institute shows that our aridity increased very much till 2010, where most of the south is semi-arid, so meaning that the limiting factor for productivity is the availability of water. And this change also just went through 2 classes of the aridity, since these areas, for example, were humid, and then it changed to semi-arid. And what we really also know is that when we look to other scenarios of aridity in terms of climate change, both using the most probable scenario of RCP 4.5 or the most extreme scenario of RCP 8.5, in both cases, we see an even increase, so the present situation of aridity, and we see an increase in aridity in the country, meaning that we will really go to more extreme situation in our country, especially in the south. So our question and the data I want to share with you is taking the advantage of the recent high-resolution remote sensing data that we have now, and using a space for time approach, meaning that we are looking to gradients in space to reproduce what will happen over time, if we can discriminate between pastures along a spatial climate gradient based on differences and similarities in their yearly phenology, and if so, what environmental factors are driving this zonation. So this is the first question I would like to show. So here, permanent grasslands and pastures in Europe are important because they cover 13% of the area, but they are also very important in Portugal since they represent more than 50% of the agriculture surface area of our country. So in this case, we make use of the data available at the Portuguese institutions of agriculture, IFAP, where they are reported the rain-fed, non-irrigated, natural and semi-natural grasslands with varying degrees of shrubs and tree cover. And in fact, we use the information from IFAP and we arrange the information from 3 types of land uses. So permanent pastures with shrubs, and permanent pastures under the cover of Quercus species. So this is a classification under the IFAP. Basically, there are different types of pastures. And we, in this case, we analyze all together, because previously we did an exploratory analysis that showed that there was not big differences that I will show afterwards on the results. That were not big differences in the results concerning these 3 types of land uses, okay? So at the end, we got 800,000 farms that we analyze. So we are really going with a lot of data at the national scale. And so we already have let's say the rain-fed patches of pasture lands. And we also took information from high-resolution vegetation phenology from Sentinel-2 with a special resolution of 10 by 10 meters. Every 5 days, it's revisited, and so we know exactly what is the productivity. And this product plant phenology index (PPI) was released since 2017 till the present. And from this type of information, we can derive 13 parameters, which I will show you later. And which allow us to understand better the plant phenology performance over the year. Of course, we had a lot of predictive variables related with topography, bioclimate, soil properties, and demographics that we use to describe some of the variables of the phenology of the pastures. And what about here? So I told you before that we are using a space for time approach. So we are looking at gradients in space to try to understand how they can occur over time with climate change. And for that, we chose from the years that we have available since 2017, we chose the year which was more normal, which was the 2018 from this series, okay? Which is represented in Portugal by this graph where it shows the more humid area, the more dry, the more warm, and the more cold. And as you can see from the most recent years, this is the one which gets the more normal pattern. So we use this here to model first this type of pastures. So what type of information do we get from satellites about the phenology? So we get all this information. So we get the productivity represented by the PPI over time along the year from January to December. And of course, from this type of annual growth of the vegetation, we can derive 13 variables, which are represented here as, for example, the minimum value, the day of the start of the season, the green up slope, the day of the maximum value, the green down slope, the day of the end of the season, total productivity, seasonal productivity, and the length of the season. So we can take a lot of variables that describe this curve. And of course, they impact productivity and the amount of animals you can have in this type of systems. So once climate is changing, we are also expecting that this will change in time. And that's why we are using the gradient in space to analyze this, okay? So what we did was pick up all these 800,000 pasture plots and look at them in a cluster analysis, so to understand if there were any similarities between them. And what strikes us is that, in fact, in Portugal, we get mainly three types of pastures, which are represented here in a visual representation of the most dominant area in these squares. So it will be very difficult to represent all the pasture patches here. So what we are representing is the dominant pasture type of land. And as you can see, we have a yellow representation here covering most of the southern part of the country, which we call southeast. We have then a dark blue, which represents the north littoral, and then this green, which represents the north center. So we got three types of cluster of pastures, and this was, we were not expecting this, and we were very curious about this. So if you can look at this graph, which is a representation what happens in the phenology curve of these three types of pastures, you see that the yellow cluster has a lower productivity, much lower than the other two, and also finishes first. So the senescence is first compared to the others. In this case, the north littoral has the one with the highest productivity, and the north center is the one which gets longer in terms of looking at longer time without being senescent. So looking at these types of curves, they are very different, and in fact they represent three types of pastures. It's very important for us that we found these three results, because it's impossible to manage or to have policies applied to this type of agriculture without knowing this. So this is an important issue. So there are three types of pastures, and we cannot treat them as one. So this is an important conclusion we got from this work. But we wanted to understand why these pastures were different. So we modeled them in relation to the environmental variables, and we tried to understand why they were classified in different clusters. And what we found is, in the case of the southeast pastures, What classifies them using machine learning algorithms, which I will not take a long time to explain, is some variables related with topography, which showed areas showed areas with lower water availability. So, for example, they have lower topographical wetness index, and which shows less water availability here. Here, higher slopes, and of course, lower aridity index. In this case, lower aridity index is more aridity, more coarse soils, and higher maximum temperatures of the warmest month, low availability of the water in the soil, and less total precipitation. So those were the most important variables that classified this yellow part. In fact, this yellow part is the one that has lower productivity, as you can see here by this graph showing the seasonal productivity compared to the other two, and also the lower end of season day, also compared to the other two. In fact, not only we got these differences, which are really relevant because you can see the dimension of the productivity range we get from different typologies, but we also get what we call a different performance. So when we compare the topographical wetness index in relation to the classification, here it's classifying. So we see that above 0, it's this yellow thing. So it's classified, the topographical wetness index means that it has less water available. Here we also have a classification based on aridity index, and in this case, it's not a non-linear response. So we get the classification when the aridity index is higher than, lower than 0.8, you get the classification of yellow. And also when you get less total precipitation, so here being positive, and as well higher temperatures. So in some way, those are they are classified as these yellow southeast pastures because they have in general low water availability and higher aridity. So what then classifies the opposite pastures, which were really productive, so the blue ones, very much productive, it's exactly the opposite of these ones. So they have more water, seen by this topographical wetness index, larger values. They have less coarse soil fraction. They have less precipitation seasonality, and they also have more soil potassium and phosphorus, so related with soil capacity. This means in some situations, so if we compare the data for the 3 types of pastures, we have more seasonal productivity, we have more maximum productivity value. The length of the growing season is similar to the yellow one, but lower than the green one. So the length of the growing season, it's also, sorry, the maximum temperature of the warmest quarter is lower than the yellow one. And the aridity index, of course, is larger, as well as the precipitation is also higher. So meaning that when we look to these tipping points, so we have more wetness, topographical wetness index, we have more salt potassium, less coarse soil fraction, more phosphorus, and intermediate precipitation seasonalities. So this north cluster is characterized by not having the limitations of water availability, which we saw on the yellow cluster. So, and on the north center pastures. So the north center pastures were classified here by a different type of thing. So in this case, the maximum temperature of the warmest month is very low compared to the other two. So if you can see here, the maximum temperature of the warmest quarter is lower, and in fact, lower summer temperatures below 29 degrees characterize this cluster, showing that the vegetation probably can maintain the growth longer and be senescent later, as you can see here by this type of behavior. So this allowed us to characterize these pastures. And we used the 2018 year to show these types of clusters. And we ask ourselves if, for example, if we use different years with different characteristics, if we would find the same type of clusters. Yes, we can find the same type of clusters in a dry year, this is 2000, a normal year, and in a warm year. Although we see some retraction of the most productive cluster, still there are 3 clusters in Portugal, okay? So if I have some more minutes, I will try to show you how we can just, taking advantage of this knowledge we have for all the country, how if we can apply this knowledge at the farm scale to allow more for a precision farming management. So we characterize the country, and now we will look to a property in one of the most arid areas of Portugal, Mértola, and so it's area with low precipitation values. Sometimes it rains 200 millimeters, although the average ranges between 400 and 600 millimeters. It's very high average annual temperature. And what you can see here, it's in between these colors, it's the amount of productivity change. And so there is, of course, changes in productivity at this type of scale. So if we have these differences in the colors in terms of productivity, we want to understand why. So we took a look to a property, in this case, this one, which was managed with cows and in a montado system. This is a drone image of the NDVI, which is, of course, the proxy of productivity. As you can see, productivity is not homogeneous at this parcel level. And we decided to understand, in this case, what was the special patterns that could represent this change in space. So by clustering a lot of topographic fixed, special fixed characteristics, we were able to find 4 clusters in the area, which represent different types of productivity. I would like also to highlight you to this blue productivity, which is the highest, and it is related with cluster 3. In this case, there are values with high sun exposure and topographic humidity. So in fact, in these areas, we have water and sun, allowing the productivity to be increased in these areas. So as you can see, productivity changes a lot at the small special scales. So with this type of maps, we can help farmers to do a more precision farming at the special scale, because this is a fixed parameters that are related to topography and that change productivity in space. But we also asked about, what about temporal precision? Can we just do the same for the temporal scale? And so you can look at here at this map between 2016 and then starting here on 17 and 2024. Look to the productivity of these 3 parcels of the property, here represented in these different colors, and the amount of precipitation in blue and the temperature here in dashed line. And what you can see just in general is that productivity follows that change in phenology, as we showed before. And it's interesting to understand in 2022, when there was a big drought, and also 2023, almost no productivity is reported. And you can also see the changes here in the graphs looking at these patches. So there's a clear impact of the limiting factors, the water availability over the years on seasonal productivity, in this case over time. And we can also, of course, see the same differences in space that we already speak, okay? So we try to characterize the time, so how time would be clustered in this situation. And we found that there are 3 clusters of time. So in one case, we found that months of January to June had like what we call in cluster 3, what we call a normal springtime, autumn springtime, which is temperature is low, the precipitation is high, and we seem to have a wet legacy from this type of cluster. But we also look to this orange part of it, when we looked to the cluster 1, and we have exactly a autumn spring different, which is temperature is low, but the precipitation is also low, meaning that we have also we can see a drought legacy when we look to the long-term data. And then, of course, we have the summer with high temperatures and low precipitation. If we look to this type of clusters, we can see that as we are approaching 2023 and 2022, we have more oranges, which is the clusters 1 with drought legacy. So we are getting, when we are getting to present time, we are getting more legacy of drought clusters, meaning that we are increasing this pattern. So, and when we try to model both temporal and spatial these areas, we can see that we have influence of short-term climate, like temperature of the last 3 months, 2 months, and precipitation of the last 2 months, together with local variables related with topography, and then variables related with climate legacy with longer time. So because I'm also running out of time, I'll really go to the take-home messages to saying that, so grace pastures were organized in 3 special continuous dominant clusters. And this was explained mostly by ecological filters that explain 70% of what is there. So even under a wide range of unknown management conditions, ecology filters explain 70% of pastures productivity. So there's no way that one size fits all agriculture policies. So we cannot deal with this type of pastures with the same policies. But we also cannot manage this type of pastures with the same type of management. So we need to tailor the pastures based on their ecological properties so that we can optimize their productivity and adapt and perform adaptations to the changes that we have in the future. So we can also apply that knowledge that we use at the national scale to do a much better farm temporal and special precision management at the farm scale. So we can do much more than we are doing, because in general, farmers exactly use the same recipe for all the area and over time. Maybe over time, not so much, but normally to all the area. So I would like, just as a final take-home message, say that there's a lot room to use ecological knowledge to improve the productivity and delivery of ecosystem services to agriculture and to the society if we apply more this type of thinking. Thank you very much, and I'm available for your questions.
So thank you, Cristina. This was wonderful. Thank you very much. And I appreciate the time that you took. I know that your time is precious and you're probably rushing away to another meeting. So thank you. We've got a few questions here. The first is a comment, which I think is important to raise from a colleague that says, thank you for talking about aridity or biodiversity loss and not agro-desertification, because we work with indigenous communities in Atacama Desert, and this concept from Altieri is very unhuman, demonizing this ecosystem where a lot of people live. So appreciate using this type of concept. So the first question is, what do you think is the main reason for this growth of semi-dry land? Would it also be influenced by intensive vegetable production?
So yeah, so the 2 drivers for desertification and just to increase in aridity are the climate, because aridity, let's say aridity is a mixture of precipitation and temperature. So we use aridity in general, and I really very much would like to visit Atacama once because it's really interesting. But what we do is we mix up temperature with precipitation, because for example, here in Mediterranean, we have precipitation in the winter, but in other areas of the world, we have precipitation in the summer, meaning that we cannot just use precipitation to compare worldwide. So aridity is much more comparable unit, but reveals mostly the climate. Of course, the climate is influenced by the vegetation that is there. I use this example of the tropical forest that when it cuts can go to a savanna. So because of the influence that the vegetation has, not only on regulating the climate itself, but also on holding the precipitation. And in the case of when we go to higher aridity areas, we also have the question of the soil. So the soil represents, it's a very long-term response to everything that happens. And so it really has a legacy that sometimes is revealed by the organic matter, by the length of the soil. And so when we are in more arid areas and in areas where precipitation varies a lot interannually, people tend to explore this in agriculture, the land in the same way. They don't respect this interannual variability. For example, in 1 year, in these arid areas, you can have 800 millimeters of precipitation. And in another year, we have 200. And of course, we cannot measure these 2 years in the same way. We cannot do agriculture in the same way in these 2 years, right? But people, of course, people are averages of everything. They tend to do the same agriculture. So sometimes there's an overexploitation because, you know, even there's an underexploitation maybe in 1 year of 800 millimeters. So we need to respect, to understand these temporal patterns. That's why I spoke about temporal patterns. And also special patterns, as you could see, microclimate really influences productivity, especially when we go to more arid areas. So we see that because water is so limiting factor, when microclimatic conditions are a little bit better because they are not so exposed to, for example, radiation, they perform differently. So, and of course, when you are in more arid areas and you have more interannual variability, sometimes there's overexploitation of the area because you cannot change the cattle in 1 year, so you tend to overgraze the areas sometimes. So this is an important issue due to the variability that occurs clearly in these areas, does not occur in the northern parts of the country, in our country. So, and I think I also must say that, of course, the way you manage land also influences not only the soil quality, and then by the soil quality, the amount of vegetation you have, and then, of course, the climate that is there in some way.
Okay, thank you. Before I go to the next question, let me just remind people, because I know that there's a much higher number of people enrolled in today's session than tomorrow's session. Let me just remind you that if you want to attend tomorrow's session, you have to register again. So there are 2 different registrations, one for today, one for tomorrow. If you haven't registered for tomorrow's session, you have to do so. And it will start again at 3 o'clock in the afternoon, Central European time. So that means 2 o'clock in Portugal and Ireland and GMT time. Now, the first comment is a compliment for you. So they're saying that presentations are top-notch with practical illustrations, which is much appreciated. So thank you. And the question is, are these pastures used to raise cattle? And if yes, could it be to introduce other races who are more adept to these changes? I believe that, I don't know if races mean breeds, different breeds or different species, but somehow animals that are more adept to these changes.
So on all these pastures, we have different things: no grazing, no domestic grazing, and grazing by all different types of animals, okay? We just didn't really select it. So they represent all the pastures that are identified as pastures in the Portuguese, let's say, agriculture inventory. So we have all mixed up. Everything is mixed up in the first data that I showed to you. In the last one, it's cows till 2022, if I'm not wrong, okay? And so it was the cattle that was used, but I don't know how to answer if we are using more adapted cattle or not, because as you could saw, 70% of the explanation that we had is mostly related at the national level to the environmental filters that are really determining what is there, okay, in terms of productivity. So I think the rest of the explanation might be related with management and type of domestic cattle, but it's a much smaller amount at the country level, of course, it's a smaller amount. So I think my idea here is also to show how putting an ecological mindset over agriculture, we can maybe have a different view.
Thank you. There are a couple of people are raising hand. I remind you that you have to write your questions or comments in the chat box, right? So the next question is there a possibility to add more organic biomass to protect the soil?
Well, naturally, I'm sure that it will be an important thing. I think there's a lot of other data, not the one I show. So what I show here in our data is soil legacy. So we know when there's more productivity in the past, the soil normally also has a higher legacy in terms of organic matter. But yes, if it's so, the organic matter naturally in the soil is related to the productivity it has. So it has low productivity, probably it would have a lower organic matter in the soil. If it has higher organic matter, if it has higher productivity, it will have higher organic matter. But, and there's a lot of other studies, which I'm not relating here, about including or not organic matter in the soil. Some of them are in the right way. I think it will depend, okay, on adding organic matter to the soils will depend in a lot of things. And I think you need to be careful about, it's not like general prescription to everything, okay? But naturally, yes, it works like that.
So another comment rather than a question is, I hope they consider the senescence of pastures on the climate change formula. I don't know if you want to comment on that.
I don't understand. So we have annual pastures. So most of the species die in the summer. And this is what I speak about senescence. And of course, what might happen is when the temperatures rise very early in spring, it can let's say induce senescence earlier than the average. I'm not sure if this is what you want to mean, but yes, senescence is natural. And as you could see in the 3 clusters, there was one where senescence was longer. It took more time for the plants to die. And that was related with maximum temperatures below 29 degrees. So places where the maximum temperatures never reach 29 degrees, and this seemed to be a tipping point.
So the other question here is from Cliff Barasa, is in agricultural systems, what practical indicators can be used to assess whether resilience is being eroded and the system is approaching a tipping point like in Kenya?
Yeah, I think that we can use different indicators because I think different indicators will give us different perspectives. So for example, I will use productivity because it's easy to approach. In remote sensing, it's cheaper than to go to the field. But I also I would use biodiversity indicators because you can have a lot of productivity, but then you just, you don't have any other things. And I also would look to the soil component because it responds in a longer term. So I will use these 3 types of indicators: productivity, and of course, all the 13 variables of senescence, of the phenology, and some indicators of biodiversity, such as birds, for example, or others, and the soil indicators. In the soil indicators, I would look to organic matter for sure, but we can also look to, for example, microbiome analysis and look at what it's there.
The next question is, in your view, to what extent are ecological insights on resilience and tipping points currently reflected in agricultural policy, and where do you see the main gaps?
Well, I don't see this type of discourse in agriculture. And I really would like to see that, because I think we need also, as I said, not one size fits all in Portugal, not even in Europe. So we need really to distinguish between these different types of systems. And of course, I think management also must be different, because for example, if you notice in Portugal, we have a problem of excess biomass in the summer. That, for example, it's one of the problems of fires. So, for example, in the north of Portugal, increasing cattle could be interesting, just to reduce the biomass and to avoid for example, big fires. But in the south, it's the opposite. You should protect the soil. You cannot just cut the shrubs, and you should not. You should really protect the soil as a first principle, because there's the fires in a large part of the south part. It's not a risky area for fires. So we should take this into account. So we should manage things in a completely different way, and the signs of policies should be different. So cutting shrubs in the south, it's criminal because you are destroying the soil and the accumulation of organic matter that takes a lot of time. And in the north, you are probably avoiding some fire risk. So completely different signs. So I think it's very important to understand these ecological systems so that we can just treat them as different, and we can do different management practices and also policies.
Okay, thank you. So again, from Cliff Baraza, to what extent can agroecological practices such as diversification or agroforestry deepen the basin of attraction and stabilize productivity under rapid climate change?
Well, theoretically, more biodiversity, and not only theoretical, we have some data from one PhD student of mine, Melanie, that shows that more diversity in the Portuguese pastures means more productivity, okay? So this is a theoretical ecological principle, but it also applies to the data, especially in the area of Portugal. So we have also results that will be published soon, where we have more biodiversity and more productivity. So normally more biodiversity occupy more niches, and if you occupy more niches, you have more productivity. So it is theoretical and it works in the south of Portugal. In relation to the agroforestry, I think that so we have the Montado system. I don't know if you know, in Portugal we have an silvopastoral system, which is the Montado, which is a savanna-like system where we have few trees. Some of them are used also to take cork, some others to other stuff. But basically, we have a livestock system we have livestock, we have trees, and we have productivity and pastures. So in this type of system, it's very important because it's a multifunctional system where you can take a lot of things from there. So it's really much more resilient than just being a pasture without trees, for example. But we should also take into account that when we really go to the south of Portugal, you cannot have the same density of trees that you have in the north, because naturally the density of trees will be lower due to ecological reasons, because we have lower amount of precipitation, okay? So it's possible, but there's a limit for the amount of trees we can have at a certain density, especially when we are going to the lower precipitation values. But yes, it's a multifunctional and a multi-diverse and a very resilient system.
Okay, thank you. Now there's a question from a final year undergraduate student of agriculture working on climate smart crops and sustainable development goals oriented interventions such as nutrient loaded biochar. And the question is, how can we locally tailored precision management practices be integrated into agroecological systems to enhance climate resilience while supporting sustainable development goals?
Well, I'm not sure if you want to answer in this direction, but what I think, when I showed the spatial clusters in a farm, you saw that there were 4 types of areas, let's say. But basically, one was more productive than the others. And so, meaning that if you put just the livestock everywhere, they probably will overgraze some areas and not so much the others. So, you can do this by, for example, some technological advances, such as, for example, I don't know the word now, the fences, the virtual fences. So instead of having physical fences, you can have virtual fences, for example, where animals have collars and they are directed to the areas where you want. So you can have, for example, in terms of livestock, a more precision management using this type of technological advancements. But of course, you can also do it by fencing, but I think it will be much more expensive. You can also, for example, treat the soils in different ways. So knowing exactly what you are expecting, for example, in terms of fertilization, in terms of letting some shrubs there growing for example, protecting the soil in slopes and so on. So there's a lot of things you can do. Managing, for example, you can manage higher slopes with maintaining with some shrubs to avoid erosion, because we know that they will hold the soil. You can just use different types of approaches. We have a lot of practices of good management, and we can use them, but in a smart way. So using exactly where they are needed and not necessarily just prescription for all the area in the same way.
So probably one of the last questions is, do you know of some experiments that are introduced with silvopastoral system?
In relation to this type of thing, I'm not sure. So we are doing some experiments, not necessarily. So we work, for example, the farmer with. Which are the owner of the land that I showed to you, is using different types of management of cattle in the area to try to find solutions and the way that better increase its productivity, and is doing, for example, so a management which makes the cattle going around, so not exactly staying all the time in the same place. So is doing this type of management, and not exactly on the area that I've showed you in other places. So I think there are some experiments with that. We didn't really look at that data. But for example, we also have some experiments of simulating the reduction in precipitation in pastures, where we just take, for example, 30% or 50% of the present precipitation to understand how the biodiversity changes and in which directions, to understand the future climate. Because what I've showed to you is what we call a space for time gradient. So we use the gradient of precipitation from the north of Portugal to the south of Portugal to show how things can work over time if we get more drier. But it's always important to test over time if things are really going in this direction. So we also are doing simulation of, we do simulation experiments where we simulate areas with lower precipitation. Okay.
Okay. Now I have one last question here. Maybe you can, if you open your chat box, but I don't think that the subject is really directed to you. José, do you have any views and insights into the narrative of livestock feed supplements such as Bovaer for reducing enteric methane emissions?
So I don't know enough about it.
Okay.
This is not related. I don't know enough. Okay.
So
I'm not the right person to answer.
Last one here. Given that land use change can reduce resilience and push system towards alternative states, how should agricultural policy account for ecological tipping points under rapid climate change?
So I think that if we identify these tipping points and if they are universal, we can, of course, account when, we can map areas which are in risk of tipping points. So, and they can have, of course, different types of management and be subsidized to that. So I think it's possible to do that with this type of work. So we identified very, very well the clusters. We identify also the tipping points that make them change. And we also know that this, although we have a tipping point and we can change it, we can avoid to change immediately. So we can sustain that change using some practices, of course. And I think it's possible, although not tested yet, but I think it's something we should test.
Very well. Okay, we're at the end of our session, so I cannot thank you enough, Cristina Branquinho and Anja Hansen, for giving us such brilliant presentations. And thank you for everybody for coming, and I hope to see you tomorrow, the same time, 3 o'clock Central European Time. And if you have any questions, please do not hesitate also to contact us. And again, let me remind you that we are recording these sessions and we will have it online, and we'll soon send you the link where you can revisit these talks. Thank you all for coming. Thank you once again, Cristina. Thank you very much. And see you all tomorrow. Thank you. Bye-bye.